Hello friends, in today's lecture, we'll try to find out one new result with the help of our this previous knowledge. Till now, what we discuss, just I will recall and then we'll go towards our main result. First, we have discussed about continuity of function. Then all the properties of continuity with examples. Second one, more stronger condition than this continuity, that is a uniform continuity. Uniform continuity. And again, we are knowing that uniform continuity implies. Now, if suppose I will take f1 and f2, both are the uniform continuous function, then we are knowing that it's uniform continuous function, then its sum is also uniform continuous. Its difference is also uniform. If we are multiplying by some scalar, then this will again uniform. But we are knowing that f1 into f2 need not be a uniform. Again, we are knowing that if I will take f1 divided by f2, where this f2 is a non-zero function, is not guarantee of uniform. Hence, if function is uniform, then their sum or difference, we can say that these are the uniform continuous, but no guarantee. Okay. Again, we are knowing that if my function here, we are knowing this continuity of this function, uniform continuity implies continuity. But when this converse is not true, means here I will write here uniform continuity implying continuity, but not converse. Converse not. So to hold converse, is there any some technique or not? We'll try to discuss. Suppose I will take here, and we are knowing we have discussed this result. This is my function, and I am taking that this is uniform continuous function. If I will take here, I am going through converse. I'm taking this is a continuous. This is a continuous function. And if this my function, this my domain is compact, if this is a compact matrix space, surely it is having guarantee of uniformly continuous. Is that right? To hold converse of this result, we should have this domain as a compact. If domain is a compact matrix space, then yes, uniform continuity, continuity implies uniform continuity. Means here, this f is function by from x to y, and this x is a compact. X is a compact, and this f is a continuous. F is a continuous if and only if f is uniform. Okay, this gives guarantee of continuity as well as uniform continuity. Again, one result we have discussed. This result was if this is matrix space XD is any non-empty subset of this X, and I am defining this function of XA is equal to infimum of d of XA, where this A is from A is uniformly continuous. Here I will real value function. the uniformly continuous. Moreover, we have discussed here, also here, so if d of xa is equal to 0, x below. We have discussed this. Okay. And here this function is the uniform continuous. Okay, I will take the help of all these results and will try to modify this result in what is my aim. Now my aim is here this way. This is my metric space XD. I will take this example of this current scenario, this is COVID situation, and this is my domain. I am taking only 2.1. Here, this is my A set. Suppose A and B, these are the two families in a one city. Suppose this is in city, A and B, these are the families in the city. Both two families are affected by COVID. Therefore, we are going to hospitalize these two families. Again, COVID situation is there, therefore we have to hospitalize in different rooms. Means A family hospitalized in this 0 room and B family admitted in room number 1 in the hospital under this F by this ambulance. Okay. Now, if there such a type of this function exists, is this function exists? Yes, surely this whole, because I am taking this as our live example. We are knowing COVID situation. Again here, A and B, these are the two families, and we are giving rooms to these two families under the condition of this COVID. Therefore, we have to give these two different rooms, that is room number 0 and room number 1. We are allotting hospital. Therefore, we are again, these are the two different families, and therefore we have need to give these two families, here, these two rooms front. That means two families should be joint. Otherwise, both are the same family, then no need to give separate rooms. Accommodation here for these two families. We are giving different room, that means surely these two families are okay. So what we'll do now, our aim is there such a type of function exists, and what will be working, what conditions should be there on try to find. Now, what I will do, I will define one function of x to r such that I will write this function of x is equal to d of xa divided by a plus d of xb. This is my function. Again, if I am defining this function in this way, then what we have to do? This function should be well defined. Well defined means this denominator part should not 0. If this is 0, then surely this type of function does not exist, and we impact this type. Therefore, this is not equal to 0. Then we have to apply, we have to check first of all, is it valid? Is this function valid? If not, then we have to add some conditions, and adding some condition, we have to convert into well-defined form. Now, what we have to do, and which condition we have to add? What I will write here, first of all, I will take if this d of xa and d of xb is equal to 0. I will try to suppose this is not a valid. Then what happens here if I am taking this condition? D of xa and d of xb, these are the metric space. And we are knowing that these are the metric, and we are knowing condition of metric both are positive. Therefore, only this condition answer there d of xa and d of xb. If this is equal to 0, we are knowing this relation, this theorem. If this is equal to 0, here. If d of x equal to 0, then immediately this is a part of closure of A. Therefore, x belong in A closure and x belong in B closure. But we are talking about here denominator part and denominator containing A and B. See here, this denominator containing A and B, and here we are getting result A bar and B bar. Is there any relation with A bar and B bar? Will give me anybody? Again here, this relation is right. A bar is equal to A, and A is closed. I leave this. Now, I will write here, suppose if A and B are closed, I'm adding now these two conditions. If A and B are closed, then what will happen? X belonging A bar, X belonging A bar, X belonging A bar is equal to A, and X belonging B bar is equal to B. Then this means X belonging A intersection B. This means X belonging A intersection B. That means here, if I am supposing that this is equal to 0, if I am supposing this is equal to 0, then we are getting X, and X is a common element of A and B. And which equation is there with us? This is a family. Both are different families. Therefore, surely we have to consider this condition. There is these two families are disjoint. Their intersection is 5. Therefore, I will try to assume, means what, which two conditions we are going to assume here up till now? A and B are closed and A intersection B. These two conditions, first and second. Moreover, A and B are non-empty. A is not equal to 5. B is not. Means A and B, these are the two non-empty subsets of our this set X, and this is closed. Moreover, these are the D. Okay. If we are considering these two conditions, then this denominator will not be. Okay. I will write here, but A intersection is 5 because these two are disjoint. We are supposing these two are disjoint. Therefore, if we are taking this as the disjoint, A plus D of XB is if we are taking. Okay, that means this is contradiction to this our supposition, and hence we should have these both are. And if this is this addition is not equal to this is not 0, that means surely this function is 25. Okay, this function is now. In any case, this is this well defined. Surely this denominator is not equal to 0. Now I will write here this given function is well defined. Therefore, f of x is equal to d of xa, d of xa plus d of b is this function is well defined. Now I will talk about whether this is continuous or moreover uniformly continuous. So we'll try to check. Now since d of xa is uniformly continuous. Is it true? Yes, because we are knowing this result. Already we are knowing this or function, this function. Therefore, we try to assume this function. Directly I'm taking using this function. Now, if this is uniformly continuous, clearly addition of two uniformly continuous function is also uniformly. Denominator is also uniformly continuous. But this numerator is uniformly continuous. This is uniformly continuous. Denominator is also uniformly continuous, and denominator is not equal to 0, but this did not guarantee this function is uniformly. Is it clear? Because we have result, functions, two functions are uniformly continuous. And this did not guarantee that their division their uh, ratio here, F1 did not be a uniformly continuous. Therefore, I will write here only this is uniformly continuous. We will talk about only continuity. Is continuous. And that means now uniformly continuous implies continuity. Therefore, I will write here this function is continuous. Moreover, denominator is continuous and denominator is not equal to 0. From this, we get this function f of x is continuous. Yes, we can find a continuous on x. We are getting this continuous. And what is the result of this continuous? If x belong in A, then what will happen? D of xa equal to 0. If d of xa equal to 0, using this, f of x equal to, what will happen? Is d of xa equal to 0, I will write here, d of xa d of xa plus d of xb. This is our function. D of xa is 0 means numerator is 0. So this function is 0 means x belong in this A, our function becomes 0. Now I will take second condition. If x belong in B, then what will happen? If x belong in B, then d of xb is equal to 0. Therefore, this function of x is d of xa divided by d of a plus b, which is equal to xa divided by d of xb is 0, d of xa only. D of xb is 0, then it cancel. System get cancelled, system get cancelled. That means, again, what we are supposing that same result we are getting. X belong in A, then x is equal. Means, again, I will write here what we are getting. Therefore, there exists this function f of x is continuous on x such that f of x is equal to, this is 0 for x belonging in A, 1 for x belonging in B. We are getting this, right? Now, tell me what is the moral of the story? What is moral? What is moral? First of all, again, I will go towards what we did, and then we will write moral of. We have this X is our metric space. This metric space having two non-empty subsets A and B. Moreover, these two subsets are defined as well as closed, then surely there exists a function f. Moreover, this function is a continuous because we have proved this function is continuous and satisfying which condition? If my point is from x immediately falling on 0, and if my point is on from b immediately falling on 1. Yes. I mean, this is very applicable to COVID situation also. How to assign all these COVID affected family in hospital room? Yes, we can generate this type of function. Very good. Will now I will define and I will write here. I will write here moral that XD be a metric space. This is metric space. A and B are the non-empty closed disjoint subsets of X, then there exists continuous function f of x, or this f function from x to r, such that f function x to r is a real value function, such that f of x is equal to 0 for x belonging a, 1 for x belonging b. Right? This theorem is stated by Urysochn. Therefore, this is called Urysochn lemma. URY SOC H and S. Urysochn lemma. Okay, this is Urysochn lemma by Urysochn. Now, my one simple question is: shall we construct this type of function? Because we are taking here this is metric space only A. B. Now I will try to add A, B, C. Because if we will again we are assuming this as an example of COVID. In one city there will not be two families. Number of families are. Suppose for this I will generalize. I will try to generalize. Now this is a question. I will try to generalize. 0, 1, 2. These are the subsets of R. Rooms from hospital, and surely these are the affecting the COVID. That's why we have to by this f function. Function is same everywhere. F function and shall we hospitalize these three families by constructing this function f in this way, and then we'll get out. Yes, this is my question. Please try to find out. Otherwise, again, I will help you. Not only for this, shall we design this function in n way for n families, n number of families. Okay, we'll try to take program on this also, and we'll try to find out program here by using this Python also. Okay, let us will do this. We'll try to think on this. Okay, we'll stop here. Thank you.